So this is the third of the three videos, course pack 909. We've done 907 and 908. So this is the third video, 909. So we want to start by factoring completely. So I want to take out 5x cubed minus 35x squared minus 40x. I want to take out a 5x, and that's going to leave me x squared minus 7x minus 8. Now I'm going to have to ask the question, what multiplies to be negative 8 and adds to be negative 7? Well, that's going to be the factors x minus 8 and x plus 1. That's fully factored. Number 2, well, the first thing I notice is there is a common factor of y squared. When I pull that out, I have y squared plus 7y minus 30. Now I need to decide what multiplies to be 30 and adds to be 7. So let's see, I'm coming up with 3 and 10. So this is y plus 10 times y minus 3. That gives me a negative, that's not a 3. That gives me a negative 30 and add up to a positive 10. So that's fully factored. Number 3, again fully factored, 12z cubed minus 44z squared minus 16z. I'm going to pull out a 4z. That's going to leave me with 3z squared minus 11z minus 4. Now I need to use California method. What multiplies to be negative 12 and add to be negative 11? I'm going to take negative 12 and positive 1. So I'm going to write these as my fractions as 3z over negative 12, net 3z over positive 1, because it's negative 12 and positive 1. This will reduce to z minus 4. This doesn't reduce. I don't know why I have a negative. That's supposed to be 3z plus 1. And that's fully factored. Number 4, I can pull out a greatest common factor of 2. So I then have x cubed plus 8. This is a sum of cubes. So this is x plus 2. Then it's going to be x squared minus 2x plus 4. And that's fully factored. Number 5, I can pull out an x squared. That leaves me 64x squared plus 48x plus 9. 64 is a perfect square. So this is 8x plus 3. 8x squared is 64x squared. 3 squared is 9. 8 times 3 is 24. Doubled is 48. So this is fully factored. On number 6, I have 4 terms, 1, 2, 3, 4 terms. I have to go ahead and factor out using factor by grouping. These first 2 terms, I'm going to pull out an x squared, which is going to leave an x plus 2. To get x plus 2 over here, I need to not just take out a 49, but a negative 49, which is going to leave x plus 2. X squared, so then I have x squared minus 49 times x plus 2. X squared minus 49, this is a difference of squares. So this is x plus 7, x minus 7, and then x plus 2. And that's fully factored. So let's look at problem number 7. Number 7 is quadratic in form. It's quadratic in form. This looks like, it looks like in the form of x squared minus 17x plus 16. So I'm going to factor it pretending it looks like this. I'm just going to use this as an x to a fourth, and this is an x squared. So the question is, what multiplies to be 16 and adds to be negative 17? That's going to be x squared minus 16, x squared minus 1. Those will multiply to be positive 16 and add to be negative 16. So that's my factoring. But x squared minus 16 is a difference of squares. So this is x plus 4. This is x minus 4. This is also a difference of squares. So this is x plus 1, and this is x minus 1. Now you might be tempted to factor the x minus 4 or the x minus 1, but these are x's, not x squares. So those 4 terms is my final answer. So let's look at number 8. Number 8, I have an x cubed, so this is a difference of cubes. So with a difference of cubes, this cube root of 64x cubed is 4x. The cube root of 125 is 5. It's a difference, so the operations are minus, plus, plus. Over here, I'm going to have the 4x squared, so that's 16x squared. Their product is going to be 20x, and over here is going to be 5 squared, or 25. That's fully factored. Number 9, again, I need to do factor by grouping. Out of the first term, I can go ahead and pull out a 4x squared, which is going to leave me with x plus, excuse me, that should be x minus 6. Here I'm going to pull out a negative 1, so I'm left with x minus 6. So now my factors are 4x squared minus 1 times x minus 6, but this first factor is a difference of 2 squares. So this again is 2x plus 1 times 2x minus 1 times my last factor of x minus 6. That's fully factored. Okay. Number 10. This is a multiplication problem. I want to go ahead and factor all 3 of these trinomials or binomials. X squared minus 5x minus 24. What multiplies to be negative 24 and adds to be negative 5. I'm going to go ahead and say that's going to be 8 and 3. X minus 8. X plus 3. That's going to give me negative 5x and a negative 24. I can factor out of this bottom one an 8x, leaving x plus 1. Remember what happens over here. I'm dividing by this, so I'm going to change it to multiplication. 1 over what multiplies to be 9 and adds to be 6. That's going to be x plus 3 squared, but I'm going to write it as x plus 3 times x plus 3. My x plus 3's here cancel, and that is all that cancels. So I end up with x minus 8 over 8x times x minus 8, that's a lie, 8x times x plus 1 times x plus 3, and that should be my answer. So again, this is my answer. All right, number 11. 11, I'm going to be doing the same thing. I want to go ahead and factor out each of these tops and bottoms, numerators, denominators of my fractions and see what I can have. I'm going to factor out a 2 and get 2 times x squared minus 100. Here I'm going to factor out a 4x and get x minus 10. Here I'm going to factor out a 7 and get x plus 3. Here I'm going to say what multiplies be negative 30 and adds to be 7. That's going to be x plus 10 times x minus 3. So I'm going to factor out this x squared minus 100 now. So this is 2 times x plus 10, x minus 10, times 7, times x plus 3, and this is times 4x, times x minus 10, times x plus 3. Hold on. Jump the gun. So it's 4x times x minus 10 times x plus 10 times x minus 3. Get out my red marker. The x plus 10s will cancel. The x minus 10s will cancel. Now this is an x plus 3, and this, now I'm going to double check, is an x minus 3, so these don't cancel. This 2 and 4 will reduce, so I'm going to get 7 times x plus 3 over 2 times x minus 3. And the one mistake I made is I dropped this x right here, so this needs to be 2x times x minus 3 in my denominator. And this is x plus 3 in my numerator. Okay. Be careful, don't drop things just by not looking at them. Number 12, my LCD, what I want to do is factor out x squared plus 5x minus 6. These are fractions that are being added or subtracted. Since they're fractions that are being added or subtracted, I want to go ahead and keep having a denominator. Having the denominator is important if that's all I have. What multiplies be negative 6 and adds to be 5? Well, that's x plus 6 times x minus 1. So that means my LCD is going to be x plus 6 times x minus 1. Since this is not an equation, it's not a large fraction or fraction within fractions, I'm going to go ahead and keep my denominators. And so what I need to decide is in this first fraction, what am I missing? I am missing the factor of x plus 6 in my denominator. So I'm going to multiply it by x plus 6. In this denominator, I'm missing the x minus 1. So I'm going to multiply top and bottom by that x minus 1. In this one, I'm not missing either of my two factors, so I'm not going to change it at all. So in this problem, let's see, I'm going to scoot down and give myself a little more room. Let's see, we're going to get rid of this. That didn't help. Here we go. Okay, so what we're going to do now is we're going to FOIL this out. My denominator is going to be x plus 6 times x minus 1. That doesn't change. First, I'm going to get x squared. Outer, I'm going to get 2x. Inner, I'm going to get negative 6x, so that's negative 4x. And last, I'm going to get negative 12. Now this is an x plus 6, so let me back up. That was a mistake. So first is x squared, outer is 2x, inner is 6x, so that's going to be 8x. And then 6 times 2 is 12, so plus 12. Okay? Minus 2 times x minus 1 is 2x minus 2 over, now again, my denominator didn't change. I made it into x plus 6 times x minus 1. And this is again minus 14 over, and again, that denominator didn't change. It is x plus 6 times x minus 1. Now that I have the denominators all the same, what I want to go ahead and do is keep that one denominator, x plus 6 times x minus 1. Combine like terms. I have 1x squared. 8x minus 2x is plus 6x. 12 minus 1 is 11. Minus 14 is negative 3. Full of mistakes today. Sorry about that. So right here, when I did negative 2 times x minus 1, I got the negative 2x, but this should have been plus 2, not minus 1. 12 plus 2 is 14 minus 14. This actually should cancel out and leave nothing here. So I did make a mistake with this negative 2 times x is negative 2x. Negative 2 times a negative 1 is a positive 2. 12 plus 2 is 14 minus 14 is 0. So this is what I have so far. But this first term I can factor out an x out of my numerator. And I'm going to get x times x plus 6 over x plus 6 times x minus 1. My x plus 6's are going to cancel out, leaving x over x minus 1. And that's my final answer. Sorry about the little mix-up there. Okay, let's go on to problem 13 and 14. Again, I'm adding here, so I want to make sure to keep the denominators. This is going to be x plus 3 times x minus 3. So my LCD, I'm going to need an x plus 3. I'm going to need an x minus 3. And because of this, I'm going to also need an x. So let's go ahead. In this denominator, I am missing the x, so I have to multiply the top by x. Here I'm missing the x plus 3, so I have to multiply the top by x plus 3. So in the top, x times x is x squared. In the denominator, I'm going to get x times x plus 3 times x minus 3. And this is going to be plus, and this is going to be 3x plus 9, if I distribute that 3 through, over x times x plus 3 times x minus 3. My denominators are now the same, so I can make it one denominator, x times x plus 3 times x minus 3. This is going to be x squared plus 3x plus 9. This is different than the answer key, but I believe this is my correct answer. I will double check and we will talk about this more in class. Lastly, we have number 14. Number 14. Let's see what we can do with number 14. I have a 2x in my denominator, so my LCD has to have a 2x. 2x squared plus 6x. I can factor a 2x out, leaving x plus 3. So what I'm missing in my LCD is an x plus 3. Again, I'm adding two fractions, so my the answer should have my LCD in the answer. So over here, all I'm missing is the x plus 3 in the denominator. So I'm going to multiply top and bottom, numerator and denominator, by x plus 3. Here, I already have it in the 2x and the x plus 3 in my denominator. So I'm just going to leave this fraction the same. If I multiply here, I get 3x plus 9 over 2x times x plus 3 plus x over 2x times x plus 3. Combine it into one fraction. Combine like terms. 3x plus 1 is 4x plus 9 over 2x times x plus 3. That should be and is my final answer. Numbers 15, 16, 17, and 18 are repeats from other pages, so you can go back and look at those answers. I'm not going to work them out. If you need to work them out more than once, you're welcome to, but you already have the answers in my work for working them out. Let's look at number 19 through 23. Write an equation for the following relationships. Y varies directly with x. If it varies directly, it's going to be y equals k x. It's never going to ask for k. You just need to know. Y varies directly with x squared and inversely with z. So y varies directly with x squared and inversely with z. You just need to know what it looks like. There should always be a k. If it's directly, it's multiplied. If it's inversely, it's divided. Z varies jointly with x and y. Saying jointly is just the same as direct. And lastly, y varies inversely with the square of x. So y varies inversely with the square of x. Y equals k divided by x squared. Number 23. The breaking weight in ounces of a styrofoam beam is directly proportional to its width in inches. A 2.5-inch beam has a breaking weight of 29 ounces. So let's set this up again. The breaking weight in ounces of a styrofoam beam is directly proportional with its width. So I know that the width is 2.5. I know the breaking weight is 29. I need to find k. So I'm going to divide by 2.5. So I'm going to get k is equal to 29 divided by 2.5. If I grab my handy dandy calculator, I'm going to get k to be 11.6. Now, so that tells me my equation is B is equal to 11.6 times W. What is the breaking weight of a 5-inch beam? A 0.5-inch beam, I should say. So my breaking weight is 11.6 times 0.5. So that's going to be 5.8 ounces is the breaking weight. And C, how wide is a beam that has a breaking weight of 37 ounces? So 11.6 times 37 is, that's incorrect. Gosh, I love when I make mistakes and I work too quickly. The 37 is not, that is my breaking weight. I want to find my width. So my breaking weight is 37. My width is what's missing. So I divide by 11.6. And I get a width of 3.19, what are we measuring in? Inches. Okay, that's the entire review. Hopefully that's helpful. Have a good day.